Yesterday we implemented the text file storage for the edit and the complete cases. Before yesterday we only had implemented the text file storage for the adds and the show cases. So when the user added to-dos, they were stored in the to-dos.txt file. So yesterday we also implemented that for edit. As you see, we get the input from the user, we subtract 1 to get the index of that number. So the user wants to edit a to-do item, so they want to provide the index of that item, and then we open the file in read mode. We get the to-dos as a list, we get a new to-do from the user, and then we replace that existing to-do with the new to-do. The new to-do will also have this break line, so that in the text file each of the to-do items is in one separate line. And then once we replace the existing to-do, we open the file in write mode and we write that updated to-dos list in the to-dos.txt file. That's the edit case. The complete case is basically the same. We get the index from the user, we get the number of the to-do item from the user, we open the file in read mode to get the to-dos list, the existing to-dos, then we subtract 1 from the number to get the index, and then we find out which of the to-dos is to be removed. For that we use the list indexing syntax, so to-dos 3 or 4 will give us that to-do. And we strip it out from break lines. So that gives us the to-do, and that removes the break line from that to-do. And then we remove that index from the to-dos. And then we open the file in write mode and we write the updated to-dos lists in the file. We also construct a message using an f string. So to-do to remove is replaced by the actual to-do that we got here. And so this is constructed as a string and we print it out in here. And that's what we did yesterday. So thank you and get ready for today's videos. See you in the next ones. Hey, welcome back. So far in our program we have used the match case statement. However, in this video you'll see that the match case statement fails at one point. And you will understand where that exactly fails and what is the alternative to fix that issue. So let's go back to our program and we will improve something now, and you'll see how match case will not serve the purpose this time, as I just mentioned. So let's run the program and I'll explain you what I want to improve. So currently, if we want to add a to-do item, we first press add, press enter, and then enter the to-do item. Play soccer, for example. You press enter, then add again, press enter, and so on. But I want to change this. I want to make this program more user-friendly by allowing the user to enter the to-do just after the add command. So in one line they can enter add, followed by the to-do item, and then they can press enter, and that will add play chess to the to-dos.txt file. So let me close the program. I hope you understand what we aim to do, and let me explain you how we can do that. So if we let the user enter add followed by the to-do item, that means in user action we're going to expect that entire string. So user action will look like this. For example, add play chess. It will contain this string. So if we execute that, user action now contains that string. And then in the match case block, can we check if that string contains the add command. So in other words, here we want to try to understand if the user meant to add something. We try to understand the user intent. Currently, we only check if the string matches this 100%. Yes, we do strip it out of the white space, but that's all. So we want this now to be more intelligent. So what I'm thinking of is to use the in operator. Let me explain what in is. This is in. If you have a string, for example add, you can check if that string is contained inside another string, such as add play chess. If you press enter, you're going to get true. And if you change the expression to something else, such as is show in that string, in that case you're going to get false. So using the in operator, we can find out if the user intends to add or do something else. This of course can also be done like this, add in user action, and you get false because user action is actually at play chess. We defined it somewhere in here. User action is this string. So we can make use of this expression now and add it in here. Add in user action. So if the case is add in user action, and we see already that we do have a red underline here, which means PyCharm already found an error. But we can try to execute it if we are not convinced that this doesn't make any sense from a syntax point of view. So if I run the script, we will get a syntax error. So case add in user action doesn't work because you cannot enter expressions after case. Case only expects a pattern such as a string. And the solution here is to use the if-else conditional block. So we want to delete match and we want to replace case with if add in user action. We want to replace case show with if show in user action. So that string in that variable. We want to replace case edit with if edit in user action. And we also want to replace case complete with if complete in user action. And also finally if exit in user action. Now we do see an underline here, which indicates that something is not correct with this code. And the problem is that we have too many levels of indentation. So notice that while true is the first level, and then it contains the code under it, so we have one indentation here, and then if should be here, but it is currently here. So we want to unindent the entire if block. To do this, you can, if you are on PyCharm, you can select the entire block by putting your cursor here, press and hold, and then drag down. Drag down until you go to the end of your if-else block. So that's the end of the block. up to the break statement, and then so you can now press Shift Tab, and that will unindent the entire block. So if I press Tab again, it goes where it was. If I press Shift Tab, it goes back. And that's it. That's the code. We can try to see if it works. So add new to do, for example. And yeah, it seems to be working, but we still get asked to enter a to-do. So we still have to fix some things here. So this is the logic now. If add is in user action, this block will be executed. So in that case, we don't want to ask the user for a to-do because we expect that the user will enter the to-do inside that variable. So therefore, we want to remove that and we want to extract that to-do from user action. We can extract the to-do using this syntax for colon inside square brackets. That will give us the part after add. So let me show you that in the Python console. Let's suppose that user action is equal to add clean the bag. Right, now user action for colon will give us clean the bag only, without the add part and without this white space. And this is called list slicing. It's a list slicing operation. So basically what we're doing here is we are extracting all the characters of the string starting from the character with index 4. So A has an index of 0, D has an index of 1, the other D has an index of 2, space has an index of 3, and C has an index of 4. So we get from C and everything that comes after C. So we get the entire string and we put it there. If you change this for colon to something else, for example 8, you're going to get that. If you change that to 9, you're going to get clean. If you change it to 11, you're going to get more and more and more. So the idea is that when I entered 8 here, what we get is the character with index 4, which is C, the character with index 5, 6, 7, and that's all. So every character that comes before 8 but after 4 is included in the slice. So 8 is not included, 9 is not included again, 11 is not included. So only 4, 5, 6, 7, 8, 9, 10, these characters are included in this slice. So that's about slicing. Slicing is helping us to extract only part of the string, only that part of the user input that we are interested in. So we store that to do in the to do variable, and that's about it. So if I run the code now, I say add fix the computer, press enter, and I say exit. The program will exit, and in todos.txt we have fixed the computer as the last to-do item. So it's working well. Let's check the show case now. So if show in user action, then we want to print out everything. So let's run this, try show. Yeah, it's working well. So show in show, it's true. So what's happening here is that the user entered simply show, and what you do is you say basically show in user action, and you get true. So that's a condition, but the entire if block is like this: if show in user action, do something. In this case, let's print hello and press enter. Oh, I've got a typo, user action, sorry. Here, user action, press enter, hello, yeah. So this is being executed whenever this is true. If it is false, such as if show in user action, in this case we will not get print hello executed. So that's how if works. Now we have multiple if conditionals here. So what's gonna happen actually here is this. The interpreter will start to execute these lines, so it asks the user for an input, and then it executes this line. It checks if add is in user action. If it is, it executes this and that and that and that. Once it finishes executing these lines, then it goes and executes this other line. It checks if show is in user action, and then it executes this if that's the case. But if you entered add as a user, then actually this will not be executed. Still, though, the interpreter will check this. So it checks every other block, this one and this one as well. So I think we have some unnecessary code here, because if the user entered add, then why does the interpreter have to check the other ones? Because logically, if the user entered add, they didn't mean show, right? So there should be a better way to do this, and I'll show you that in the next video. So see you there. Currently our program checks if add is in user action, and it executes these lines. But then it also checks if show is in user action in the same user input, which is not necessary. So to optimize our program for speed, we don't want to execute this line. To do that, you simply have to change if to elif, and do the same for edit, elif edit, elif complete, and elif exit. So by doing that, what we do is this. Let's say the user entered add play chess. The program will check this condition. If this is true, it will execute this, and then it will not execute anything else in the while loop. Of course, it will execute the last line outside the while loop, which is what we want. But these code lines are not to be executed, so that speeds up the program. If the user enters show, for example, then the program will check if add in user action. If that's not the case, it checks the next block, which is elif show. And if that's the case, so if this is true, then it will execute these, and then these other ones will not be executed. So the program will not check conditions anymore. If the user enters complete, then the program will first check if add is in the user input. If it's not, it will check if show is in user input. If not, it will check if edit is in user input. If that's not the case, it will check if complete is in user action. So that's the case, so it will execute this, but then it will not execute the other conditional. So as you are able to understand probably, is that the conditions are checked on a priority of rank, or which is closer to the top of the script. That could mean if you expect the users to enter mostly an add command, so if most of the time they want to add to-do items, then it could be more logical to have this add condition, the first one. Because if this was the last one, and you know that most of the time the user will enter add, then these other conditions will be checked. Check this, no, check that, no, check that, no, and then the user checks the last one. So it makes sense to have the most popular cases on top. Right, I hope that makes sense. We also have something called else. So we have if, we have elif, and we can also add an else here, which works like this. Else, a colon, print, command is not valid, which will be executed if, for example, the user enters something like they didn't enter add, they didn't enter show, nor edit, nor complete, nor exit, but they enter something like crash or soften. So in that case, the program will say this command is not valid, because what the program does is it checks this condition, it checks that, the other elif, 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 and then if none of these conditions were true, then the program will execute something else. That's the meaning of else. So we know that the user didn't enter the correct command, and we print out this string. So back again to add in user action, we implemented that, and show, this is also implemented. We expect the user to enter simply show, not followed by anything else. But then in edit, we expect the user to enter something like edit followed by a number, such as 1. So first perhaps they want to see the list of to-dos, and then they say edit number 2. So let's count for that scenario here. So elif edit in user action, we get the number from the user, but we don't want to get the number through an input function. We don't want to ask the user to enter a number. We want to get the number from this variable. So a number is equal to user action, and we use slicing again. So this time would be we have 0 for E, 1, 2, 3, then the user will have a space, so 4 for the space, and 5. So we expect to have the number at position 5. So everything after that is going to be the number. Now if we try to execute this, and before I execute it, I'll also print out the number to see what we get. So execute, first show, then edit 2, press enter, and we get an error. So in line 26, because I entered number before defining it, so I have to put it here, run again, show, edit number 2, press enter, and of course we get an error this time, unsupported operand type for minus, so str and int. Maybe you notice it that we didn't convert the number to a string, because what's happening is that when the user enters edit 2, that is a string, so something like this, that's a string. So first we want to extract it, so user action 5, that will give us 2, but you see this is a string, so we want to convert it using int in front. So here goes int, and that expression goes inside int. And then we increase the number by 1 to adjust for the index system. Then we open the todos.txt as a file, read the to-dos, then the new to-do. Now this is asking for a new to-do. So the user will enter a new to-do, and then we change to-dos number. We have the number in here, and new to-do plus a backslash. So new to-do is the new to-do of the user. Let's try this. Show edit to, enter new to-do. That would be play chess instead of play soccer, and press enter. Show and play chess is the second item now. So that's about edit and complete. Now let's implement this as well. So the idea goes the same. We don't want to get the number with another input function. We want to get it from the user action variable, user action. So can you guess this time what's the number? So that would be 0, 1, 2, 3, 4, 5, 6, 7, 8 for the space after complete, and 9 for the number. So the number could also be 2 digits. So we have to say everything that comes after 9, starting at 9 and everything after that. And convert it into an int. Like that. And then the number goes in here. We strip it out and we pop it out in here. So that should work. Show complete 2. Show and play chess is completed. That's about this video. So that's a complete if else block. You always start the block with if, and if you want you can continue it with elif, checking and checking and checking for different conditions. And if none of those conditions is satisfied, perhaps you want to do something else. So every other condition that is not one of these conditions is included by else. And in that case you want to say, oh, that's a totally different thing. And so you print out something like command is not valid. So that's a lot to digest, but this is very crucial to learn. So I hope you understand the difference between if and match case. Thanks a lot. I'll talk to you in the next videos. Hey, welcome to today's code experiments. Today you're gonna learn how to use Boolean operators. So far in the course, we have encountered comparison operators, which are things like greater than, so 3 is greater than 2, that's a comparison operator, or the opposite of that, or the equality operator, which is also a comparison operator. And we also learned math operators such as 3 plus 2 or 3 times 5, so multiplication, addition. All those are operators. Now, what are Boolean operators? Well, first of all, don't confuse Boolean operators with Boolean data type. Boolean data types are true and false. So just like we have strings, data types, we also have these data types, which are usually produced as an output of comparison operations. Now, what are Boolean operators? Well, let's look at our code, what we have so far. So, Boolean operators are used usually in conjunction with an if, else block of code. So currently in the code, if we run it, the user can enter a new to-do item by typing add, followed by the to-do item itself. So for example, add get the car. Now, what if you wanted to also allow the user to enter new as an alternative to add? For example, new get the car. So in this case, you also want to add that get the car to-do item in the to-do list, just like you do when the user enters add. So you're just giving the user one more option how to add to-do items. Now the question is, how can you implement that in the code? So let's see how we can do that. To add items, to add new to-do items, this code is executed. So that code reads the existing file and appends the to-do that the user enters here in the list, and then writes that list in the file again. So we end up with a new updated to-do list. So this code is only executed if add is in user action. Now, what if we also want to allow new to be in the user action? Well, you can do that using the OR operator. And we say if add in user action or new, so the string new in user action. So now we have an if line with two optional or two OR conditions. So if one of these is true, this code will be executed. In other words, if the user has at least one of these, so either add or new, the code will be executed. So I'll run the code again. Try new get the car. We again get a new prompt. This time I want to show the to-do items, and get the car is added as the last to-do item successfully. So likewise, you could add more conditions here. For example, you add another OR operator and then followed by the condition. For example, maybe you want to allow the user to enter more, so if more in user action, and in that case, if the user enters more here by grocery and show, and we'll see that groceries, so buy grocery is added in here. Anyway, I'll remove that because that's a bit too much. What if we had and instead of that? So and is the next Boolean operator. And let's see how the code output will change with that. So again, I'll try new, fix the door, press enter. And in this case, we got this. Output command is not valid. That means else. So the code under else was executed, which in other words means that this code was never executed, and that means this condition was never true. So if this is true, this selection here, if it is evaluated to true, then we get these executed. Otherwise, this selection here is not executed. And this was not evaluated to true because this text here didn't have add and new at the same time. So that selection is only evaluated to true when both add and new are in the user action. So that is not the case, and that is not what we want here. So OR would make more sense. And the last operator that I'll introduce you is not, the not operator. And that is the negation of the in operator. So it negates the thing it has in front. In this case, it says if at is not in user action. So if I run this code now, and if I press add, fix the door, again it says command is not valid because this is evaluated to true only if add is not in that piece of text. In this case, add is there, therefore this is not evaluated true. So let's try the opposite. For example, hello, fix the door. Press enter, press show, and again we don't get any output. So this is what happened when we did that, hello, fix the door, then this was evaluated to true because add was not in that text. So these were executed and the text from the position 4 up to the end was added to the to-do list, as we can see here. And the same happened in here. So when the user entered show in here, and then the program again checks if add is not in user action, and in this text again add is not in that text. Therefore this code will be executed and elif will never be executed. So the interpreter will never reach the elif condition because this was evaluated to true when the user entered show. Right. So that was about Boolean operators. I'll just keep the code as it was. This is good enough. But that was just to show you some experiments, how the code changes, so you understand these kinds of operators as well. Now you are aware of these operators, and whenever you want to work on double conditions, you can use them. So thanks a lot, and I'll talk to you later. Hey, welcome back. In today's bonus example, we're going to write a program which checks the strength of a password. The program will behave like this. So in the command line, the program asks the user to enter a password. So let's say we enter hello 456 and a capital H. You press enter, you get this output, strong password. So the program checked this password and it returned strong password. So this was a strong password because it fulfilled 3 conditions. First, it was 8 characters or longer. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 characters in total. The second condition was that the password contained at least 1 digit. This has 3 digits here, so it fulfills the second condition as well. And the third condition is it contains at least 1 uppercase letter. So here we have this big H, capital H, so an uppercase letter. If one of these conditions wouldn't be true, we would get here weak password. So that is a program we're going to write in this video. Everything, of course, starts with getting input from the user. Enter new password. And then we check this password against those 3 conditions. So let's focus on those conditions one by one. Let's think of the first condition, which is the password should be 8 characters or longer. So first of all, you should think, how can you check the number of characters? That you can do with the len function. So if the user enters as a password, for example, hello, len would output 5. So now we can check if the length is equal or greater than 8. So we use a conditional. If len of password is greater or equal than 8, then what do we do if that is the case? So do we print out strong password? No, because we want to print out strong passwords at the end after we check all the three conditions. However, you should be very careful here. Logically, these conditions are separate conditions, which means you're not going to write something like if and then elif, and then you check if there is a number in password, and then again you check elif uppercase. So this is not how it works, because these conditions are independent of each other. So we're going to have separate if else blocks for each of the conditions. So the first block is the block that checks the length of the password, and then we're going to record the result of each condition somewhere. So we're talking about several conditions, and the result of each condition, maybe it should be stored in a list. So let's call this list result. It's going to be empty for now, and then, so let me make some space here, and then if length is greater or equal than 8, so we say result.append true. So the first item of the list is going to be either true or false. So else result.append false. So the first item will represent the first condition, the length condition. So if we print out result and we execute this code, so the user enters hello, we press enter, we get false. So false is inside a list. We run again if the user entered hello, hello, so 2 hellos, which means a long password, and we get true there. Similarly, we're going to add the other conditions in this list, because that's what lists are for. So whenever you want to store multiple things, whatever they are, they could be numbers, they could be strings, they could be Boolean data types such as true or false, which represent these conditions. So whatever they represent, multiple things are stored in a list. So that's the first thing we store in a list. Then we check for the next condition, which is if there is a number inside the string. To check if there is a number inside the string, you do this. So let's say this is a string, dot is digit is a method that strings have, and it returns false or true. But the problem is, see now, if we write a digit inside the string such as 8, and you press enter again, you get false. So it's not as easy as you think, because isDigit actually checks if this entire thing is a digit, not if that string has a digit character inside. So it checks if, for example, 8 is digit, then you get true. If it was A, you get false. If it's 99, you get true, so it's a number. But if at least one, if there is one letter or other characters that is not a number, we get false. Therefore, the only solution we could think of here is to iterate over password characters. So we check every single character, which means if the password is, for example, hello9, we will check first the first H for H in passwords, and we say i.isDigit, and that will check if H is a digit. If it is, it will return true. If it's not, it will return false. So this returns true or false. We want to make use of that, and this is a bit maybe tricky, but not that hard to understand. So if we create a variable here and we'll set it to false, and then here we say if is digit is equal to true. And this is what will happen here. So the interpreter will first run this code. That's another condition, so it will do whatever it does with that. And then it goes in here. Digit is a variable and it will be set to false. So its value is false for now. And then the interpreter iterates over the characters of the passwords. Let's say the first character is age. So the interpreter checks if age is a digit. Age is not a digit, therefore this will not be executed because this is evaluated with false. So if age is not a digit, this is false. And since this is false, this is not executed. Otherwise, if when we go to the other characters such as E, O, L, these are also not digits, so this will not be executed. That means digit will stay false. But if there is one character which is a number, let's say at the end there is a number 8, and we say if 8 is digit and that is true, in that case this will be executed. So the value of the digit variable will change to true. If we have more characters in that string after the number, again, for example, for W in password, if W is digit, it's not a digit, so this will not be executed. That means the last value that was assigned to digit will remain in place. The last value was true because we had that number before W, and so digit will be equal to true if at least one number exists in the string, in the password. So at the end of this for loop, we're going to have a value for digit which will be either false or true. And then we can check again if digit, and then we exit the for loop. So after the loop ends, then we want to say result.append digit. So digit will be either true or false. Therefore, at this point, result is going to contain two items. So let's try this. Hello 9044, a long password, so we have true for the length, true for the digits. Let's try again. Let's just say hello this time. We have false because it's not long enough, and we have false again because it doesn't have a number. So far it's working well. Next, we want to check if there is at least one uppercase character. The idea here is exactly the same as with isDigit. So when we check a string with isUpper is the method, you get false if the string is not entirely uppercase. So for example, if A and you have B uppercase, you get false. So all the items of the string have to be uppercase. So now we get true because B is the only character there. The result is true. So what we can do is, again, we assign a variable, let's say upper or uppercase. So that is a variable which is set to false. So this is like the hypothesis logic. When you start to do some research, you want to prove something, then you start with assuming that your hypothesis is false, and then you try to check to prove it. So we assume that the string doesn't have any uppercase characters. Therefore, we say for I in password again, if I is upper. So don't confuse upper with isUpper. What upper does is it returns a string, which is the uppercase version of that string. And what isUpper does is it returns a boolean data type, not a string data type, so false or true. Just wanted to be clear about that. And if isUpper, then we change uppercase to true. And finally, we exit the for loop, so you see the indentation level here, and we say result.append and uppercase this time. We run the script. Hello there, 8H. We get true for everything. And finally, how to get that strong password or weak password result instead of this list. So we want to have the output more user-friendly. Either show strong password or weak password. To do that, you can use the all function. All is going to get results as input. So all is a function that see what it returns. So if we say hello, we get false. So all returns false when at least one of the items of the result list is false. Let me print out the result list as well so you see what's going on. So again, hello, false, false, false. This is also false. If at least one of them is true, For example, we have a digit, we have false, true for digit, false for uppercase, but the result is again false. So this is again considered a weak password. If everything is strong and tidy like that, lots of numbers, uppercase letters, and then we get true. So the all function returns true when all the items of the list are true booleans. Now we can make use of that and say if all result is equal to true, print strong password, print, else print weak password. Let's make a break line in here. We have this suggestion here by PyCharm, but we will fix that in just a bit. So if we run the script again, hello, uppercase letters and numbers as well. So this is a strong password, therefore we get strong password here, because this is equal to true. If the password was short, no uppercase letters, no digits, we would get weak password as a result. So you can remove that print result if you like, and you get only that output, so more cleaner. Now we can fix this here. So if you roll over your cursor, this says that expression can be simplified, which is true. So the way you can simplify this is by just removing that. So that is equivalent to that. When you say if all result, what you mean is that all result is actually true. So Python is simplifying that by allowing you to not have to type is equal to true. And that is the suggested way to do it. Now I don't want to close the video here because I want to introduce you to a new data type, dictionaries. What are dictionaries? Well, dictionaries are somehow similar to lists, but also very different. So result is a list in our program, and it looks like this. So it's a list of booleans in this case. The problem with lists is that sometimes you want to know what each of these represents. So we want to know that false represents the length condition, true represents the digit existence condition, and false represent the uppercase condition. You know, that is different from, let's say, when you have a list of temperatures and all the temperatures are not needed to be associated with something because it's just a series of temperatures. But here we might need to know what's going on more as a programmer. In that case, what we want to do is we want to use a dictionary. So a result is equal to a list here with square brackets, but to create a dictionary you use curly brackets. And then once I did that, you see here this append method is highlighted because a dictionary doesn't have an append method. So if you open the Python console, if you check for dir list, you see that somewhere in here we have the append method. But for dictionaries, if you do list dict, so dict is the type that represents dictionaries. Sorry, not list dict, but dir dict. So I meant to show you the methods associated with dictionaries. So you'll see that the append method is not part of dictionaries. So how do we add items to a dictionary? Well, let me show that to you. Again, a list looks like this when it's empty, and if it does have some items, then it will look something like, let's say it has numbers 14, 20, 30. And a dictionary uses curly brackets and it is divided by commas, so its items are also divided by commas, but then it doesn't have single numbers, but it does have these so-called keys. So height 14, width 20, and depth 30. So we have 3 items, 1 here, 2, and 3. Actually the last comma we don't need it, so 3 items, 2 commas. Same for list, 3 items, 2 commas. So a dictionary, the items of the dictionary are compound. They are made of a key, so that is the key. It is a string in this case, and that is the value. And the key and the value are divided by this column. So that's one item, a key value pair, and that's the second item, key value pair again, and then the third item. So you press enter and B is a dictionary now. You see the difference here? So a dictionary could be more useful when the data are different from each other. So this is the height and this represents the width and this represents the depth. So there is a need to know what each of these values are. And that is what dictionaries are for. Now, to help you understand the difference between lists and dictionaries better, I want to make an example from the physical world. Let's suppose we are in this cafe and the barista has these 2 shelves on the left and on the right. On the left, the barista has a series of jars of different sizes, glass jars, and they all have sugar. Some jars have more, some others have less. Then on the right side, there's another shelf where the barista has these jars, but they all have different things inside. So one jar has sugar, the other has salt, another one has coffee, another jar has butter. No, the jars of this second shelf is better to be labeled, because these are different items. On the left side shelf, this is not necessary because you know that all these are jars with sugar. So it's enough to just have like a label on the shelf, which could be the variable of this list of sugar jars. So when you have a list of similar items, then you don't need to name each item. But when you have a list of different items, then this list is better to be a dictionary. So a dictionary where each item is labeled. I hope that makes sense. So that's the difference between lists and dictionaries, and the other difference is the way you access items. So for a list, you just say, give me the item with index 1, and it gives you 20. So that. For dictionaries, you do the same thing, but instead of indexes, you specify, guess it, the key. So B, square brackets, just like we have with lists, square brackets, and then you write down the string representing the key for the value you want to get. So B width will give you the value of width. With that in mind, let's go back to our code. So result is an empty dictionary now, and we want to populate it with values. So to populate a dictionary with values, you don't use append as we did with lists, but you do the same syntax. So let's say we want to add a new item here, B area, and that is equal to 100. Let it be a number. And then you say B, and you see that area has been added as a value, so key and value as an item of the dictionary. So we can do the same thing here. We say result. Let's write a key name for this, so let it be the length. So the length will be equal to true. Else, we do the same. So I'm copying that here, but this will be false. And then for digits, result, currently we append this, but now we want to append false or true to digits, maybe a string called digits. So that is equal to the variable digit. So again, we are adding keys and values. Here we add the key length, which is equal to either true or false, depending on which of these will be executed. And then we add another key value pair. The key is digits, the value is the value of this variable, which is either false or true. And then again here, result. Let's say uppercase, just like that, is equal to uppercase, which is again true or false. So let's see what we get. Run the script, enter hello 9, and that's what we get from this print function. So that prints out the result dictionary. Length is the key of this first item. So that's the first item. The key length, and false is the value of that item because the length was not greater or equal than 8. Therefore, this was executed. And then digits is true because we have this number. And uppercase, the key here is false. So now we have a better view of the data structure. This is an improvement from the list data structure because we also see the associated descriptions of each of these values. So this helps us as a programmer maintain the program better. The user, though, will want to see either strong password or weak password at the end. Now, I know you're thinking, why do we get strong password here? Well, that is because this looks at the keys of the dictionary. So, if you want to check the truthness of the values, you want to apply the .values method here. What that does is this. So let's say B is the dictionary, right? In here, results is the dictionary. In our console, B is the dictionary. So if you say B.values, what you get is only the values of the dictionary. So this is like a list type of object. It's called a dict value object, but it resembles a list. So it has the same structure as a list. And if we run the script now and we say hello 9 again, then we get weak password because this time this all is checking the values of this dictionary, which if you want to see them, you can say result.values. So hello 9, we get the dictionary, the full dictionary, and then we get the dict values print here from this line, and then we get weak passwords because at least one of these values is false, so not all of them are true. And that's about dictionaries. So you should use them whenever you want to know what each of the data is about. And this is usually the case when the data inside your sequence, which could be a list or dictionary, are needed to be known to you as a programmer what they are. So it's easier for you to understand the data, to read the code. So think of the keys of the dictionary as metadata of the values. The values are the central points of the dictionary, of course. So you want to store your data in the values, but the keys are some additional data, so-called metadata. So thanks a lot for following this long video, but lots of good information that will help you go forward with the course. So thanks a lot and see you later.